Hi everyone, my name is Sydney Nader, and today I'm going to be walking through a face detection code where it detects where your face is on the screen and then it keeps your face centered as you move within a certain region. So I'm going to dive right in. Here at the top I've listed ENME435 transforms information source just in case you're unfamiliar. I did some research and utilized CV2.warp-affine, and that was very useful for me when, working with the frames and keeping everything relatively translated as I move my face around. So here in lines 5 through 6, we can see me just importing necessary packages, 8 and 9, initializing the width and the height of the camera, 11 through 13, we're initializing the camera. Lines 15 through 16, I'm calculating the frames per second according to my laptop speed and processing purposes. This was played with until my face was moving at the correct rate. And then we can see I calculate the frame totals so that I know the duration of the video based on parameters that I can enter in this variable. So 18 and 19, we can see defining video output parameters. And then we start a frame counter initialization variable here, line 21. Lines 23 and 24, we can see defining the location of the model in the prototext. I dove into that a little earlier in my other facial detection code, so you should definitely go reference that. It could be pretty useful to understanding this one as well. And now diving more into the code and what you're actually going to see as an output, I initialize a blank black canvas. So this is what the background is going to be as my face is moving around and remaining centered. So I'll demonstrate that in a couple minutes. So now lines 26 through 61 are the heart of the code. So we have a while loop that runs until the respective frames have been collected to form a 15-second video. And then here in the early code, we're just reading in the frame, constructing the blob, providing input data to the network, and passing all those good things in through the model so that we can calculate detections. So then we can see this for loop is detecting, it's calculating confidence that a face has been detected based on the model. And then if the confidence is 0.5, so it's collecting information, this loop will begin collecting information if the confidence of the detection is greater than 50. So if we are more than 50% sure that a face has been detected based on the model in the earlier code, then this code will run. So then we define some start and ending points of the bounding box, create text to show the confidence percentage of the face, and then this is a calculation for the y coordinate to move as the face moves. So a lot of this code will become apparent in the demonstration portion. Excuse that. And then we can see calculating the center of the face. This was just some geometry based on the bounding box. Lines 50 and 51, calculate the translation vector to keep the face centered. So this is very important when working with line 60, the warp-affine CV2 call. And then we just see here, this will place almost like a target on my face. So again, once I run the code, you'll see that. And this part of the code is the main thing that translates the frame by the opposite of the translation vector. So this ensures that as I move, my face stays centered, and then that background will compensate for if I'm moving more to the left or more to the right of the frame, and my camera isn't within those dimensions. And then we will display the resulting frame and write that frame to an MP4. So I'm gonna now demonstrate for you guys my face moving around. I'm gonna show all 4 quadrants of my camera. So I'll move top left, top right, bottom right, and you guys will get to see that. So let's move to a demonstration. Alright, so now moving into a live demonstration, I'm going to activate my workspace in Python. And I'm going to run the code, so work 6.2.py. And then what's going to happen is my face is going to come up. I'm going to have a cross with a dot in the middle. I chose red and yellow for some terrapin pride. And then we're going to see how my face remains centered on the screen no matter where I move to. So just waiting for the code to get started up. Okay, so we can see as I move around, it moves with me. And I'm going to do this for 15 seconds because that's how long I want the video to be. But I can move quickly, I can move slowly over here, up, down. Yeah, so then we can see the output video here, facial detection video. That's my previous video from my previous project, part of the project. So if you're interested in that. And then we can just see me moving around. Yeah, and then you can see here in the top left, you can see the confidence. So you can see, as my face is moving, the confidence kind of decreases, and then as I'm more stable, the confidence is pretty much 100. And the confidence is really high throughout this algorithm. I'm going to play it one more time, but you can see that it really never drops below the 96, 97 region as I'm moving at a steady pace. So super great algorithm. It's following my face really nicely, keeping the center really well. So yeah, this is something I was super happy about. Okay, so this is the last video that I will be making for ENME435. If you've been following along, thank you so much. I appreciate your support and interest, and hopefully, as I mentioned in my previous video, I'll have more personal projects coming in soon. But this has been a super crazy ride, super fun, super great to learn so many new things in Python, working with CB2 and all of those things. So yeah, super excited to see where the future takes me, and this is me signing off from undergrad. So thanks for following my journey, and roll terps.